Okay, hello everyone. I welcomes to all in our lecture series on Jacobian. Here it is written as Jacobian of two variables uv with respect to xy, or it is written as del uv by del xy. That means Jacobian of uv two variables with respect to another two variables x y. Okay, likewise three variables also we can write, that we are going to discuss in our forthcoming classes. Whatever we are going to discuss in this lecture series, that will be based upon your NEP syllabus. In this lecture series, we are going to discuss these topics: definition and application of Jacobian, properties and corresponding proofs of Jacobian, discussion of important questions on Jacobian, change or transformation of variables in integrals and corresponding questions. This lecture series is very much essential for BSc, BTech, MSc, MTech and various entrance examinations for both physics and mathematics honor students. Okay, so let us start our first topic: definition and application of Jacobian. Here is the simple definition of Jacobian. Here you can see, if u and v be function of two independent variables x and y, then the determinant, this one, is called Jacobian of uv with respect to x and y. Here u is the function of xy. Here xy are two independent variables. That means del x by del y equal to 0, or del y by del x equal to 0. There is no connection between x and y. V also function of x and y. Then this determinant del u by del x, del u by del y, del v by del x, del v by del y is called Jacobian of uv with respect to xy. And here I am going to tell to you that if I am going to interchange these rows and column, then the determinant value also will be same. That means if I am going to write this one like this, del u by del x, this row I am going to change as column, del u by del x. Here del u by del y I am going to write like this, del u by del y, del v by del x, this row if I am going to write as column, del v by del y, then the determinant value of these two determinant will be same. So this determinant you can found some other book, it is written like this. So there is no difference between these two determinants. So some books written in this format, some books are written in this format. Okay, so I suggest you just remember in this format. Okay, okay. And here you just keep these things in your mind, that Jacobian of uv with respect to xy, that means these two variables is transforming another two new variables x and y with the help of Jacobian. Okay, in short, this determinant, this one, is represented as del uv by del xy, or j del in bracket del uv by del xy. This is the Jacobian of two variables. The Jacobian of three variables can be written as j uvw by xyz. Here three variables uvw transform to another three new variables x, y, z. It is written as del uvw by del xyz. Corresponding determinant is this one, del u by del x, del u by del y, del u by del z. Okay, del v by del x, del v by del y, del v by del z, del w by del x, del w by del y, del w by del z. Likewise, if you are going to interchange row and column, the determinant value is not going to change. That means some other books, if you are going to follow, may they written like this, del u by del x, del u by del y. This row, this first row will be the first column, del u by del y, del u by del z, and this second row will be second column, that is your del v by del x, del v by del y, del v by del z. Third row will be third column, del w by del x, del w by del y, del w by del z. So if I am going to compare these two determinants, there is no difference. Some books written in this format, some books are written in this format. I suggest you just remember this way. Okay, here this determinant represents Jacobian of u v w with respect to x y z. Okay, so this is in the form of 2D, this is in the form of 4D, you can say. This is belongs to two variables, this is belongs to three variables. Okay, likewise Jacobian of more variables can be also defined. That means if I am going to consider del u v w t with respect to del x y z and p, also we can write a determinant here for two variables, 2 cross 2 determinant. Here three variables, 3 cross 3 determinant we have to construct. Here four variables, we have to construct 4 cross 4 determinant. Okay, okay, now we are going to go for the applications of Jacobian. So again I am going to suggest you just remember this matrix and this matrix. So whenever we are going to say uv, Jacobian of uv with respect to xy, here along the row uu xy, here along the row second row vv xy, for three variables along the row uu xyz, then second row vvv xyz, third row www xyz. Now we are going to move to discuss the applications of Jacobian, where the Jacobian can be used in our physics. First, physics and mathematics itself. First, it is used in integrations. Jacobian determinant is used in the substitution rule for multivariable integrals. Coordinate transformations. The Jacobian is used to transform integrals from one coordinate system to another, such as Cartesian to polar or spherical polar coordinates. Third one, robotic kinematics. In robotics, the Jacobian describes the relationship between robot's joint angles, that means your input, and the position and orientation of its end effectors. End effector, that means output. That means it is Jacobian used to provide the relationship between input and output in a robotic kinematics. Okay, okay. Next, optimization. In fields like machine learning, Jacobian is used to calculate gradients, which are very much essential for optimizing model parameters. Jacobian used for solving equations also. Jacobian is also fundamental to computational process for solving systems of equations. Okay, in our lecture series, we are going to discuss these two applications of Jacobian. Okay, in our next class, we are going to discuss properties of Jacobian and their proof. Then after, we are going to discuss questions based upon these properties. Okay, so for today class is this much. Thank you so much for watching this video. Thank you.